Hello everyone, welcome to the solution of LeetCode problem 1761 named minimum degree of a connected trio in a graph. In this problem, we are given an undirected graph and you are given an integer n, which is the number of nodes in the graph, and the array edge where the edge of I is u of I and v of I indicates that there will be an undirected edge between the u and v. Now, a connected trio is a set of three nodes where there is an edge between every pair of them. So here we can see that the node 1, 2, and 3 is the connected trio because we can go 1 from 2, 2 from 3, and 3 from 1. So there is a node, there is an edge between the every nodes. Now, the degree of a connected trio is the number of edges where one endpoint is in the trio and other is not. So here if we see this, the edges for this is 3 because the connection between 3 and 6, one endpoint is presented here 3, another endpoint is presented outside the trio 6. Similarly, for the connection 2, 5, one endpoint is connected here in the 2 and another endpoint is connected here in the 5. And for the connection 4, 1, one endpoint is connected to the 4, another endpoint is connected to 1. So for all of these three edges, which is 4, 1, 3, 6, and 2, 5, one endpoint is presented in the trio and another is not. So here, so for this, the degree of the connected trio is 3. Now we have to return the minimum degree of a connected trio in the graph. And if no connected trio exists, we have to simply return -1. So here in the first example, we can see that the degree of the connected trio is 6, which is the 4, 1, 2, 5, and 3, 6. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken this example, which is 1. And initially, the graph is this. So here, this 1, 2, 3, these are the trio or the connected trio because we can move from any point to any point here. Or we can say that there is an edge between every pair of node in this trio. And here the answer will be this node plus this edge plus this edge and this edge. So here the answer will be 3 because for all of these red edge, one endpoint is presented in the trio but another is not. One is presented in the trio, another is not. One is presented in the trio, another is not. So before jumping into the solution, let's understand how we can solve this. Initially, as this is a graph problem, at first we have to make adjacency list. So here, if we make the adjacency list, it will become something like this. For the node 4, it has a connection between 1 and 4. So we will apply the 4 here and 1 here. That means there is a connection between 4 and 1 and 1 and 4. Similarly, for the connection 1 and 2, we can add 2 here, and for the 2, we can add 1 here. Now for the connection 2 and 5, we can add 5 here, and in the 5, we can add 2. For the connection 1 and 3, we can add 3 here, and for the 3, we can add 1 here. For the connection 3 and 2, we can add 2 here in the 3, we can add 3 in the 2. For the connection 3 and 6, we can add 6 in the adjacency list of 3, and we can add 3 in the adjacency list of 6. Now, for each of the edge, we will calculate the in degree. So here, the in degree of 4, that means for this edge, the in degree of 4 will be 1, in degree of 1 will be 1. And for this edge, the in degree of 1 will be 2, and in degree of 2 will be 1. Now for this edge, in degree of 2, in degree of 2 will become 2, and in degree of 5 become 1. For this edge, 1 and 3, in degree of 1 will become 3, and in degree of 3 will become 1. For this 3 and 2, in degree of 3 will become 2, and in degree of 2 will become 3. Now, for this 3 and 6, in degree of 3 will become 3, and in degree of 6 will become 1. So far, we have found the in degree of all of the 6 nodes, which is 3, 3, 3, 1, 1, and 1. And in degree basically defined is that the number of connection coming towards the node. Now, we have to run 3 loops, basically nested loops, for each of the I from 1 to n, for each of the j from 1 to n, and for each of the k from 1 to n. We have to first check whether there is a connection or there is the connection between every pairs of node or not, for every I, j, and k, whether they are connected or not. So here, if the I, j, and k is connected, that means in the adjacency list, they will be present. Now, after checking whether this I, j, and k are connected to each other or not, we have to calculate the equation will be in degree of I minus 2, in degree of j minus 2, in degree of k minus 2 plus. Why? Because suppose for this node 1, it here the in degree is 3, but here 2 of the edges is connected between 1 and 2 and 1 and 3. So in the calculation of the answer, we cannot consider these 2 edges. So for each of the triode, we have to subtract 2 from its in degree. Finally, the equation will become in degree of I plus in degree of j plus in degree of k minus 6. So here, the node 1, 2, and 3 are the triode. So here, the summation of in degree will be 3 plus 3 plus 3 minus 6. That means 9 minus 6, which is 3. So here, these 3 basically represents this node, this edge, this edge, and this edge. And this is how basically we're gonna solve this problem. I hope you understood the algorithm. Now let's move on to the code. Now here, the code is pretty simple. At first, we are given a function named minimum triode degree, which is integer n and the h as the parameter. Now we are initializing an in degree of n plus 1 and the adjacency list of vector of set. Now for each of the edges, we have to increment the in degree of first value and the second value and insert the first value in the adjacency list of second value and insert the second value in the adjacency list of first value. Now we have to initialize answer with integer maximum variable. Now for each of the I from 1 to n, if in degree of I less than 2, that means this I cannot be a part of any of the triad. So we have to simply continue. Similarly, for each of the j from I plus 1 to n, if in degree of j less than 2, that means this j cannot be part of any of the triad. So we have to simply continue. And if there is no connection between I and j, that means j is absent from the adjacency list of I. We have to again continue. After that, we have to run again a loop from j plus 1 to n. And here again, we have to check if the degree of k is less than 2. That means if it is, that means the node k cannot become a part of any of the triad. So we have to continue. Otherwise, if there is a connection between I and j, j and k and I, the answer will be minimum of answer and in degree of I plus in degree of j plus in degree of k minus 6. Finally, if the answer is equal to integer max, that means we did not find any of the triad, we have to return -1. Otherwise, we have to return the answer. Thank you everyone for watching the code. We will get back soon with another LeetCode solution.